Now we are ready to do part B. For part B, we will change the problem. Now imagine that part B first. Let me put part B here. And F node is not large enough to make the block move. So the block is not moving. The block is at rest. What is the problem? What is this problem again? There is a block sitting on the table. There is force F node acting on this block at a given angle theta. There is force of friction between the surface and the block. And what I want to find? I want to find force of friction. What will be magnitude of force of friction in this problem? Okay, so now the block is not moving. Life is much more complicated because we know that in this case, force of friction will be force of static friction. First question that I want to ask you, is force of friction is mu n? Not anymore. Before that, actually, we had mu kinetic n here. The block was moving. Now the force of friction is not mu n, and we need to figure out what is it. So to have a big picture, I will adopt a diagram from Jan Colley's book. What I will do, I will draw applied force applied to this block versus force of friction. So when I don't apply any force, when F node is 0, then force of friction is 0. Now as my force increases and increases that I apply to the block, force of friction also increases. But if F node is not large enough to make this block moving, the block is still at rest. It's not moving, it's at rest. And force of friction here is less than coefficient of friction times normal force. So I'm increasing and this is straight line, sorry. Increasing and increasing my applied force. Force of friction is getting larger and larger. Larger and larger. But finally, my applied force is large enough for this block to be ready to move. So here it is at rest. This is static friction, and this everything in blue is static. Let's do this. So I will make it red. This is static. This is static. So at this point, the block is still at rest, but ready to move. It is ready to move. This is the largest magnitude of force of friction that you can achieve. At this point, the magnitude of force of friction is equal to mu static, coefficient of static friction times n. And then, as you know, for most objects, as soon as you start moving them, then it becomes a little bit easy to move them. The kinetic coefficient of kinetic friction is a little bit smaller. That's why there is jump down, and here the block is moving. This is kinetic friction, and force of friction everywhere along this line is equal to mu kinetic times n, as we had in our part A when the block was moving. So when it is moving, no trouble. We know the magnitude of coefficient of force of friction. Now, when it is static, what we need to figure out is, where are we? So along this pink line, the block is at rest. Here the force of friction reaches its maximum value, but it is still at rest. Where are we? Is force of friction less than mu n or it is mu static n. In our problem, it is said that the block is at rest, there is force F naught that is not enough to move force of friction. So we are somewhere here when the block is at rest and force of friction is less than mu n. What I need to do? I need to find this magnitude of force of friction, and to do that, I need to write Fx max. So the law is the same, Fx max, Fy may. We already have free body diagram. We already have our coordinate system. But we have a problem here because force of friction is not mu n anymore. What is it? F naught cosine theta. This is my x component of F naught. I don't know the magnitude of force of friction. I'm looking for it. And the object is still at rest. So my acceleration in x direction is 0. So this is the correct equation now for this problem. When the block is at rest, F naught is not, force F naught is not large enough to move it. Can I solve for force of friction? Yes. Normal force, by the way, no changes. But force of friction in this part B is equal to F naught cosine theta. So it compensates x component of F naught to keep the object at rest, to have net force in x direction 0, which keeps it at rest. And that was part B.